Welcome to Classwork 9.3, Textbook Section 9.5. Today we're going to be talking about parametric equations. We're just going to scratch the surface here. When you guys take calculus, you're going to go much more deeply into this topic. But for now, we'll just introduce the concept. So look at example 1. Graph the plane curve defined by the parametric equations x equals t squared minus 1, y equals 2t, and it gives us some restriction on t. So always note that restriction. What that means is we're going to start at -2. So on my chart, notice how I put txy, -2, -1, 0, 1, 2. I like to think of this as like a time parameter. So it's like saying if t is -2, so think of that as like a point in time. What is x and y? So plug in -2 to your x equation, your y equation. So -2 squared is 4 minus 1, that's 3. 2 times -2 is -4. Now essentially you plug it in and get all the points. So I'll just follow it. 0, -2, -1, 0, 0, 2, 3, 4. And I'm going to plot it. So my first point, notice how right here, that is your first point. And this one is going to be our last point. So let's graph it. 3, -4. That is right over here. 0, -2. Then we have -1, 0, 0, 2, and 3, 4. I'm going to connect the curve here. Notice how it's kind of like a sideways parabola. But notice how there are no arrows anywhere. The curve is that segment. And I'm going to indicate these arrows, and I recommend you do this too. That indicates a direction. So imagine there's like a particle right here. And the particle is actually moving along this path. That's the idea of parametric equations, and you're really going to talk about this idea in calculus. And to make it more clear, I'm going to put start, and I'm going to put finish here. And again, the whole idea here is you have to understand that it's like saying there's a particle starting here, and it's moving along this curve. That's our first example. Next example. Sketch the plane curve represented by the parametric equations and really underline or highlight this part, eliminating the parameter. What that means is you want to eliminate t. So the easiest way to do that is to simply solve for t. So we're going to square both sides. X squared equals t. Highlight that. You want to solve for t because now look at our equation. Y equals 1/2 t plus 1. Plug this thing in for t. Y equals 1/2 x squared plus 1. That would be like the rectangular representation of these parameters, and that's what we're going to graph. Now let's graph this parabola. So if I were to ask you to graph this equation right here, we can pick some pretty easy points, right? We can say like if x is 0, then y is 1. Let's pick even numbers because they're going to get squared and halved. So I'll pick 2. 2 squared is 4, half of 4 is 2 plus 1 is 3. So 2, 3. We'll do one more. Let's pick 4, the next even number. That's 16, divided by 2 is 8, plus 1 is 9. And then there's our first couple of points. Now, remember, if we're graphing a parabola, we all know there's symmetry, right? So your instinct should be to graph your full parabola, both sides like that. However, if you were to do that, that graph is incorrect. And that's because if you were to think about the whole idea of parametric equations, this extra parameter, this t, changes everything. Notice the definitions here. It says x is the root of t, right there. So for example, let's say I wanted to get this point right here, -2, 3. What value of t can I plug in to this right here to create -2 for x? This is impossible. There is no value here, which means these values don't exist on your graph. So I actually need to get rid of this whole left side. This graph isn't here on the left. If you look at this very carefully, I'll highlight this right here. That creates a restriction on t. T, because of the root, has to be greater than or equal to 0, which means t equals 0 is actually the first value of t we can actually use. And if t is 0, you get x is 0, y is 1. And now let's start plugging in some values for t. Let's say t was 4. If t is 4, then x is 2. And if t is 4, you get 3, 2, 3. So notice how that point does line up. And then we can continue this if we want to get more points. So on this graph, let's illustrate a couple things. Here's our start. Our finish is to infinity. And then the particle is going to move up forever. So again, it's going to start here, and it moves up this line like that. Okay, last one. Sketch the plane curve represented by the parametric equations below. Let's highlight this here. That's our restriction from 0 to pi. And notice how it wants to eliminate the parameter again. So again, that means we have to eliminate t. So this one we gotta be a little bit creative. We have x equals 5 cosine t, y equals 2 sine t. What we're gonna use is this fact, that sine squared theta plus cosine squared theta equals 1. Now remember, theta can be anything, so we can actually just put a t here to make it a little easier to use here. So I'm going to try to use this equation right now. Let's divide 5 to both sides here. Let's divide 2 here. So what I'm going to do is actually solve for cosine t for now, and solve for sine t. Now I'm going to square both sides. So I have cosine squared t is equal to x squared over 25. Sine squared t is equal to y squared over 4. Now how do we use that key fact, the Pythagorean identity? Just add them together. You just write them in. So notice how I have cosine squared equals x squared over 25. You can plug that in right here. That would mean x squared over 25 plus y squared over 4 has to equal 1. So again, essentially, we're going to add these together. And there is our actual equation. We've done it. We've eliminated the parameter. Now hopefully you recall this from your Algebra 2 class. What is that? That is actually an ellipse. Now if you forget how to do that, that's okay. As long as you remember the general shape, you can always make a chart. So on the side, I'm just going to draw my TXY chart right here. TXY. And t is 0 to pi. So let's pick easy ones. 0, pi over 2, and pi. Let's plug in 0. So that would be 5, 0, 0, 2, -5, 0. So I'll plug those points in. And let's connect them. So notice how That's my top half of the ellipse. Now again, you have to realize I did not draw this bottom half. And the bottom half isn't there because of this restriction. The restriction says stop at pi, which means here's our first point. This 0, 5, 0 part. And our last point's right there. Right there is our last point, which means we are not continuing that graph on the bottom half. So I'm going to get rid of this. So our start is right here, our finish is right here, and I'm going to draw these arrows to indicate the path the particle would be moving. So imagine this particle moving along this path like that. Okay, that's it.